Hello. The the simplest possible example of the simultaneous equations model is a 2 by 2 model like this. There are two endogenous variables, y1, y2, and y1 is determined by y2, y2 is determined by y1. In some sense, this is very similar to the supply and demand functions. And yet this is, and say, but I do not put that interpretation here. It is a general, let's think it as a general system of equations. And this is the structural form. It shows how y2 affects at y1 and y1 affects y2. There are many examples like fall into this case. Like, for example, say y1 is GDP and y2 is, say, internet speed, for example. So better internet promotes maybe economic development of it. At the same time, as economy develops more, no, internet will be better. What's what? I don't know. I don't know what's the answer, but it is just an example. Another example. Say I play, like, say y1 is the time playing video game, and y2 is obesity, BMI index. So I am fat, so I don't. So it's difficult to like say no, like don't use this example. So sad. What else? Anyhow, so you can imagine a lot of examples. Y2 affects y1, but at the same time, y1 affects y2. You can make up examples. Be more creative. Anyhow, so it is a structural form, and we have parameters, gamma 1, gamma 2. Of course, epsilon 1, epsilon 2 are errors. And here, based on the two equations, you can solve the equations for y1 and y2, which is pretty simple. System of linear equations. I'm not going to show you how to do this. Anyhow, this is the solution. This is the solution, and this is the reduced form. So y1 is the equilibrium y1, which is determined by epsilon 1, epsilon 2, and parameters. So there is no endogenous variable on the right-hand side. And y2, another endogenous variable, is determined by this. And there is no endogenous variable on the right-hand side, right? So this is the difference between structural form and the reduced form equations. So reduced form is for the equilibrium solution, and structural form is for the underlying relationship. And in this case, the parameters are not identified. So even if so, the parameters are defined in the structural form because that's what we assume. But in the real data, we can utilize only the reduced form because this is the equilibrium. This is what we observe. So you have to rely on the reduced form equations. But as you can see, nothing we can do here because y1 is simply some weighted sum of two errors, and y2 is another sum of errors multiplied by the parameter. So nothing. There is nothing you can do. So there is nothing you can do. That's the end of the story here. We cannot identify model number 1. So it does not work. So there is no variable, and so then let's see what happens. Usually a typical mistake. So from this reduced form equations, you have to tell that it cannot be identified. Everything is just error. So the equilibrium is simply a noise, does not give us any information. Then what happens if you regress y1 on y2? This is a typical mistake. For example, like say y1, it looks like a regression of y1 on y2. So it looks like a regression of GDP growth rate on internet speed. If you ignore this, if you ignore the second equation, yes, it looks like a regression, but the problem here is y2 is endogenous because it is correlated with epsilon1. So it is correlated with epsilon1 because epsilon1 affects y1 and then it affects y2. So epsilon1 affects y2. So it's endogenous. That's if you ignore that, let's see what you get. Under the wrong assumption that y2 is exogenous, from the first equation, you may want to estimate the coefficient by this. The classical linear regression result, and then using you know y1 and y2 are determined this way. So plug these solutions into here and here, and calculate the expectation. This is what you get. And it's totally something totally wrong, totally different. I don't know what it means. It doesn't mean anything. It's nothing. So there will be some correlation between y1 and y2, but it does not capture either gamma 1 or gamma 2. So it equals, the equality holds only under a very specific case, especially this. So gamma 2 equals to 0 means y1 does not, the second equation does not exist. That means y2 should be exogenous. So this holds only when y2 is exogenous, which is very restrictive assumption. Therefore, this is a typical, very common mistake by many people. If you ignore, if you want to just estimate one equation in the simultaneous equations model, then it may be wrong, especially when you ignore the endogeneity. You have to look at the model first and tell what is endogenous, and then have to think about that. And by the way, here another common issue here is that, so usually many students are confused by this. Say when y2 increases by 1 unit, then y1 increases. Then y1 increases, then by the second equation, y2 increases. Then by the first equation, the increment in y affects y1, so increases. So increase, and some students believe that they are going to diverge. That may be true, but usually that is not true. So we'll show you. And simply speaking, like the spiral effects, if you do that many times, the increment will be very small. Then there must be finite limit, so that will be the equilibrium. It's like exactly the supply and demand things. So when there is an excessive supply, the price goes down, and then there will be excessive demand, then price goes up, and then excessive supply goes down. Blah, blah, blah. If you go forever, it does not converge. Of course, it converges to a point. So same thing here. But we have to think about the mathematical condition to have a unique solution. That is, the denominator should be non-zero. If the denominator is 0, close to 0, if this converges to 0, then y1 and y2 will diverge. So that is the condition to have a unique, well-defined equilibrium. So simply speaking, gamma 1 times gamma 2 must be different from 1. If gamma 1 times gamma 2 equals to 1, then that happens. They go to the infinity at the same time. So then there is no solution. There is no equilibrium. Therefore, we will maintain this assumption. So when you state the system of equations, you have to put this as an assumption. Otherwise, there may be no equilibrium, or the equilibrium may be infinite. So your model may not be well defined. So that's another interesting characteristic of simultaneous equations model. So excuse me. It's a typo. So it should, of course, it should be different. It should be it must be crossed out. It must be different. It must be different, and it is not that restrictive. Then you may wonder, then it's a problem. Yes, that is a problem, but it is not a serious problem. So because it's just one point. So gamma 1, gamma 2 can take any number, but they just don't need to be at a specific point, which is a very small probability. So we call this a measure zero set. So this is simply a measure zero set. So it won't happen except for special cases. And also, like in most cases, like this assumption is coming from the economic theory, like supply and demand, or the Cournot duopoly. Anyhow, we observe an equilibrium. That means the equilibrium exists. So you may deduce from the observation that the equilibrium is well defined. Otherwise, the market has to explode. The market has to go crazy. But if you don't observe a strange pattern in the equilibrium, then assuming that is not a big problem. Okay, and I will use some another slides for graphs, and we'll continue to generalize the model. I will stop here and continue in the next one. See you later.